I think you are all are well. Okay. Those students are preparing for SSC JE, JE, and different types of AE JE. This session is very important for those students. Previous year questions is very important for our exam. I am a student of mechanical engineering. My name is Buddhadev Pal. I don't know how I help you, but if this session is helpful for you, please one like for this session. Okay. If I wrong any question, please forgive me. And as think a brother of your brother, let's start the questions. I have already completed the three classes. If you not watching these previous questions, and please go through the playlist and you can see easily. Okay, let's start. Questions number 76. An axial is applied on a circular section diameter. This is the circular section. Axial load each act. Diameter is capital D. If the same load is applied on the hollow circular section, inner diameter is d by 2. Same load is applied for the hollow circular shape, inner diameter is d by 2. The ratio of the stress in two cases would be, okay, area of the hollow circular pi by 4 d square, and area of the hollow circular shape pi by 4 outer dia square minus inner dia square. So pi by 4 into outer dia d square minus inner dia d by 2 d square by 4. So 3 d square by 4. Okay. We will stress is equal to force per unit area. Okay, stress for the solid circular shaft sigma 1, let's assume sigma 1 equal to area force per unit area. Force is p, applied force is p per unit area pi by 4 d square, and sigma 2 is pi p by area pi by 4 d square, pi by 4 into 3 d square by 4, 3 d square by 4. If we divide them, sigma 1 by sigma 2 equal to this is cancel out, this is cancel out, so 4 by 3 is remaining. So answer A is the correct. Let's check the answer. I think calculation is mistake. The 3 by 4 is the answer. Let's check this process. The ratio of the stresses in two cases. We know the pi by 4 d square by pi by 4 into pi by 4 force per unit area. Sorry friends, force per unit area. This is under pi by 4 d square, and this is pi by 4 into d inner d minus d square by 4 by p, because this is the ratio and the sigma 1 by sigma 2. So this is inversion उलट जाएगा, ठीक है. So this is cancel and remaining is 3 square d square by 4 d square. This is capital D also. So 3 by 4 is the answer. Next question. A steel rod of 20 mm diameter, okay, 50 mm long, is the subject to axial pull of the 30 kilonewton. E equal to given. What is the elongation? Delta L equal to PL by AE. This is the formula. Here we put the data in this equation. We can get easily the elongation of the rod. What is the force? Force is 30 kilonewton. 30 into 10 to the 3, and length is given 500 mm. 1 mm equal to 10 to the minus 3 meter. Okay, so 0.5 meter divided by area pi by 4 into 0.02 whole square into e 2 into 10 to the 5. If you solve this equation, you can get the answer. Let's check the answer. I told you this process how to solve this question. Let's check. If you put the data in this equation and then solve it, then you can get 0.239 mm. Okay. Next question. What is the strain in a bar having cross section 50 mm square subjected to the 10 kilonewton axial load, assuming the Young's modulus E? What is the stress? Stress equal to force per unit area. Force per unit area E. You can put the data in this equation. Force P equal to 10 into 10 to the 3 divided by area in mm. Then first you convert this meter square. Okay. If you not convert, then not necessary to convert, because the Young model was also given you Newton per mm square in megapascals or megapascal. So I cannot change the units. 50 pi by 4 into, अच्छा area is given, sorry not pi by 4, this यार डिलीट कर देते. ठीक है, देखो strain equal to force by AE. Force is the 10 into 10 to the 3, area is 50, and Young modulus is 2 into 10 to the 5. You solve this equation, you can get the answer easily. Okay, 0 से 0 कैंसिल आउट हो जाएगा, एंड 5 into 2 यानी 10, so 10 to the 3 by 10 into 10 to the 5. So this is cancel out, and 2 1 by 10 to the 3, 0.01. I think A is the answer. Let's check. A is the answer. Here is the answer. Okay. When a bar of the length L, width B, and thickness T is subjected to a push of P, its length, width, and the thickness increases. Length, width decreases. Length increases. Width of the thickness decreases. Length increases. Width and thickness increases. This is a bar. Okay. This is a bar. If we push P by P force, what is the happened? This is happened. So length is decreases. Both in increases, no. Length is increases, no. Length is decreases. Okay, let's check next. Width is increases. Width increases, and thickness also increases. D is the answer. Next question. A member of the length 200 mm and diameter 25 mm is subjected to a tensile load of 20 kilonewton. The final length of the member is found to be 22 mm. The percentage increase in the length of the member. What is the percentage increase? Delta L by L percent. What is the delta L? 20 diameter is given. The final length is given 20. So 220 minus 200 divided by 200. So and this is 20 by 200. Am I right? 100 into 10, so 10%. Let's check the answer. Yes, D is the answer, 10%. Here the solution also is given. Okay, as I say, the same is the process to solve. The poisonous ratio of a material whose Young's modulus is 1.2 into 10 to the power 5 Newton per mm square, and the modulus of rigidity is given 4.8 into 24 Newton per mm square. We know the Poisson's ratio mu modulus of rigidity is G and the Young modulus E. What is the relationship both of them? E equal to 2G into 1 plus mu. In this equation, G is 4.8 into 20, mu is 1.2, E is 1.2 into 10 to the power 5. Then you solve the mu and you get the mu easily. Here the solution mu is 0.25 if you solve this equation. Next question. See this figure. Okay. If the net decrease in the length of the two bars is 0.35 mm, the force P will have the value. Take modulus of what is the force P? Okay, and the take modulus of elasticity of 20 kilo Newton per mm square. This is the ratio of the area of this section, or this is for this section. Okay, change in total elongation equal to delta L of steel plus delta L of the brass, PL by AE of the steel, PL by AE of the brass. L by A of the steel is given. Then you can put the values in this equation. You can solve the P easily. Graph which represents stress characteristic of plastic plastic material. Okay, this is elastic and plastic. This is elastic and plastic material. C is the answer. This is the elastic plastic with strain hardening. Friends, please suggest me which topics you want to learn, which type of question you want to practice. Okay. Next question: when a body is subjected to thermal stresses, the thermal strain is thermal strain thermal strain delta sorry thermal strain E thermal equal to thermal strain equal to T. Okay, delta T. thermal strain equal to L alpha delta T. Alpha delta T. So directly proportional to the square of the coefficient? No. Directly proportional coefficient of the linear expansion? Yes, I think B is the correct. Let's check. Yes, B is the correct. Thermal stress equal to E alpha delta T, directly proportional to the coefficient, thermal coefficient. Next question, friends. What is the unit of stress? Stress also, unit of the stress also is same for of the pressure. Okay, pressure force per unit area, Newton pressure. Which of the following relation is made by the Hooke's law? Stress is directly proportional to strain. Stress is inversely proportional to strain. Stress is directly proportional to square of strain. Stress is inversely proportional to square of strain. A is the answer. Stress is directly proportional to strain. Next question. A steel bar is subjected to an axial pull of 84 kilonewton. Stress induced into bar 140 newton per mm square. Young modulus is given. Then the longitudinal strain produced will be longitudinal strain will be this is the longitudinal strain equal force per unit area AE. Okay, force per area is called the stresses. So stress per unit by stress per young modulus. Stress is 140 and the young modulus 2 into 10 to the power 5. Then you can get the answer 0.007. Which of following is the exact relation between the elasticity E and the modulus of rigidity G? We know the relation E equal to 2G into 1 plus mu. 2G into 1 plus Poisson's ratio. C is the answer. Modulus of rigidity is defined as the ratio of modulus of the rigidity G equal to volumetric stress plus into volumetric strain, shear stress into shear strain, lateral stress into lateral strain, linear stress into linear strain, shear stress by shear strain. A steel wire is stretched by a load. If the radius of the wire is doubled, then the modulus of elasticity will. Modulus of elasticity of any material modulus become half, become double, remains unaffected, become 1/4. Steel wire. Okay, the radius of the wire is double. Modulus of elasticity of material of any material is modulus of elasticity is same. Okay, so remains unaffected. फिर भी चेक कर लेते हैं आंसर. Yes, I am right. Modulus of the elasticity is a property of a material which depends upon material temperature and the pressure. So if the radius of the wire is double, then it remains unaffected. Anybody live? No. If you are coming live, so we discuss the question answers together. It's very amazing for us, but this is a small channel, so nobody in live. I read the question and say the answer. It's okay. Let's next question. If you new my channel, please subscribe my channel and please on the notification for the joining live. Question is the exact relation between the modulus of rigidity C, modulus of elasticity E, and the Poisson's ratio nu I think the position is a mu. I will take and see relation with the nu and the G is C. So E equal to 2C. E equal to 2C. E equal to 2C into 1 plus mu. The answer E equal to 2C 1 plus mu. C is the answer. This is the important format. Okay, remember it. This type of format is coming next exams pattern. Okay, because in this type of patterns already comes many times. So trend, our trend is changing. So this type of question is coming. So mu equal to 3k minus 2g by 6k plus 2g. Remember it. Okay, friends. Next question. A steel rail rigid fixed its end is assume the stress free at 20 degrees centigrade if the stress required causing the buckling of the rail 70 megapascal at the what temperature will the rail buckle स्ट्रेस फ्री करना चाहता है ठीक है रिजिड फिक्स्ड ends its end okay what is given find out the temperature okay stress equal to E alpha delta T where stress is given minus 75 in megapascal okay minus 75 equal to E gigapascal so 200 into 10 to the power 3 into alpha 12.5 into 10 to the power minus 6 into delta T. Here you solve the and then the temperature is coming. Temperature is coming uh, minus 10 degrees centigrade. Okay. T1 is given this question 20 degrees centigrade. So we put T1 equal to 20. For a ductile material, toughness is the measure of resistance of stretching, resistance to indentation, ability to absorb the energy till fracture, ability to absorb energy till elastic limit. Toughness is ability to absorb the energy till fracture. फ्रैक्चर होने तक जो एनर्जी एक मटेरियल toughness. Toughness is ability to material to absorb the energy till fracture. Resilience is ability to absorb the energy till elastic limit. What is the proof resilience? If you know what is the proof resilience, please comment the answer on the chat box. If you know, ask the question. Me, I give you the answer next classes. Next question. The ultimate tensile strength of the mild steel is the engineering stress strain curve refers to yield stress, maximum stress, proportional limit, and the fracture stresses. Ultimate tensile stress is the maximum stress. This is the ultimate stress and the maximum stress point. Okay. Next question. A tapering conical bar of 1.5 length has the diameter of 21 mm and the 60 mm at the two ends. Find the elongation. For the elongation for the taper bar, only the you remember the formula, then you can solve this question easily. PL by pi by 4. You put delta D1 is 1.5 and d2 is 21 mm. So converts, sorry, this is L 1.5 and this is d1 d2. Okay, then P also given, exile load, so E also given. You can solve this equation easily. Okay, this is the solution. 5 by 25 by 33 mm. Next question, Poisson's ratio is measured of deformation in a material in a direction perpendicular to the direction of the applied force and is the ratio of the lateral strain to longitudinal strain for the rubber. Its value is mu. Poisson's ratio for the rubber is 0.5, the maximum. There is some data for the Poisson's ratio. Rubber is 0.5, which is maximum. The Poisson's ratio is -1 to 0.5. Okay, value, or 0 to 0.5 we can say. The stainless steel 0.30 to 0.31, steel 0.27 to 0.30, cast iron 0.21 to 26, sand 0.2 to 0.455. Next question, the stress developed on the perpendicular plane area of the body due to the external forces is known as. Stress perpendicular in the force body external forces, this is called the normal stress. Perpendicular, no? This is normal stress. Stress developed on a perpendicular plane area of a body due to external applied force is known as the normal stress. Tangential stress or the shear stress developed in the tangential plane area of the body due to the external applied force is known as the tangential stress or the shear stress. Next question, what is the bulk modulus of the elasticity of water at NTP on the normal temperature and the pressure? You remember this data for bulk modulus elasticity of the water of the normal temperature and pressure 2.07 into 10 to the 6 kilopascal. 2.07 into 10 to the 6 kilopascal. During the testing in UTM, what is the full form of UTM? Please comment on the chat box. What is the full form of the UTM? The terms lower yield points and the upper yield points are specially mentioned in which type of the material? For the ductile material under tension, ductile material during tensile testing. A shear strain induced in body of volume V. Due to this, shapes change occur without change in volume, length change occur without change in volume, area change occur without change in volume, volume change occur across along the angle. Shear strain used in a body of a volume V. I think BD is the answer. Let's check. A is the answer. Shape change occur without change in volume. Yes, yes. This is the shear stress. Shear stress occur with shape change without change in volume. Volume तो constant ही रहेगा. Volume क्यों change होगा? Okay. So this is the end question of this session. Thank you for watching my video. If it is helpful for you, please like for this session and subscribe to my channel and join live every day. Thank you so much, friends.